Hey everybody. So in this video we are going to discuss how red blood cells are broken down, what they are broken down into, and then how your body reuses those components. Because at the end of the day, your body wants to use and reuse all of its components as often as possible because it doesn't want to waste anything. So with that said, it all happens in these three locations: spleen, liver, and red bone marrow. They have macrophages that are going to be responsible for breaking down these red blood cells. Let's specifically talk about hemoglobin first. So, hemoglobin is broken down into two main parts: the heme and the globin, which we discussed in previous slides. The heme group is going to be broken down further into two components: porphyrin and iron. The iron is something we already talked about a little bit because of its importance in binding with oxygen. Porphyrin, not so much. We didn't talk too much about that. So it's important to note that heme is made of iron, but also porphyrin. So let's see what happens now with porphyrin. Porphyrin. It is going to get further broken down into two parts: biliverdin, which is green, and bilirubin, which is orange pigment. Once broken down, these get released into the blood. They're going to bind with albumins, enter the liver specifically, and then eventually get broken down by bacteria. That said, if these do not get broken down, we may start to see some pigmentation of our waste products. These are indications that our body is not breaking these down, right? So if everything works according to plan, your pee and your poop looks normal because that's what you're supposed to do. However, if these pigments remain in your digestive tract, you might see brown or orange stool. And if these remain in your blood and are not broken down within your urinary system, um, you may see an amber color in your urine. Right. So these are ways that we can see: is our body breaking down the porphyrin the right way? Are we breaking down our red blood cells correctly? So these are two indicators that show us if it's not working correctly. Let's talk iron. So iron is going to get released into the bloodstream, and then it's going to bind to transferrin, which is a type of beta globulin. From here, it can either go to the red bone marrow or the liver. If iron goes back to bone marrow, it's going to recreate heme to be reused as a red blood cell again. So we can just immediately bring it right back to the bone marrow where we're making red blood cells and reuse it. If not, we may go to the liver, right? This will all depend on the negative feedback pathway, if we have too much or if we need more iron. But if we go to the liver, it just gets stored for later on. So in case our body needs iron later on. Next, what happens to the globin, right? The globin is broken down into amino acids, like we discussed earlier. Let me go back here. So the globin is going to get broken down into amino acids, and then from here, those amino acids can just get reused for any type of protein synthesis throughout the body. So as we discussed, the amino acids create proteins. Proteins are used to make everything in the body. In this case, they were used to create the globin. But once we break it back down, we can either reuse it to make more red blood cells, or we can just use those amino acids somewhere else. So, with that said, if you have any questions on what happens during the breakdown of red blood cells, please let me know.